wondered how something's made, or how it could be, I don't know, remade? If you have, I'm happy to show you what I'm talking about. Right now, I'm playing with a box of life. And I'm looking at all the different methods or sides that this box has. How is this useful for if I needed to make anything at all? We'll find out. Question: what is an orthographic projection? Well, a projection is something that is viewed on, say, another object. So thinking about a movie is projected, or a PowerPoint is projected. So that is something where I'm taking an image and I'm seeing it on a different plane. And when I'm seeing it on the different plane, this is usually a flat, two-dimensional plane. The orthographic portion is the different views. So, of an object, let's say that, of an object. So if I have a cereal box, like I have here, I'm going to create an orthographic projection. And to help me, we use this thing called a glass box method. So a glass box method is as if we're taking the object and we're going to put it within its own glass box. And anything that is viewed from that side, if I manipulate it, becomes the projection. So there are three main views that we always use, and that is the top, the front, shows the most detail. So what, if I was looking at a cereal box, what would you first look at? Would you look at this small side, or would you look at the bigger side with the title? We would usually look at the bigger side with the title, thus that becomes our front view. Once we figure out what our front view is and all the other projections, we can start going into making detailed drawings. A detailed drawing is something that would include dimensions, annotations that of notes, materials, how it connects, so joinery methods. A lot of these would be going into our detailed drawing. The detailed drawing concept is just how much information can you get so that anyone who needs to remake this could remake it. We would also start talking about technical drawings. A technical drawing is something that's going to include a lot more dimensions. It may have other views like section views, or other information that would help us for the manufacturing of the object. Our detailed drawings can include technical drawings as well as all the other information. It's, once again, it's pretty much saying as much detail as possible. So, as you know, this is your basic cereal box. This would be known as an orthographic projection or a detailed view or technical drawing when we get into more details. So this right here is your 3D view. Notice the 3D view is in the top right part of your screen. And this will always be in this location. The other notice that you have to realize is right here that I just drew. That's as if I'm looking bird's eye. And that bird's eye view is known as the top view. Over here, you'll see that I have my top view. And to make this a detailed view drawing, I would add annotations such as a dimension or notes. So a note would be made from cardboard. The other thing you have to note is that this has two openings. So you can see that this has two flaps. The other view that you would see is your front view. So the front view is the view that you're most likely going to see the most detail. So a front view shows the most detail and usually also includes the longest edge. So in this case, the longest edge is our height, but also shows us our width. A majority of our dimensions will start here on this view. Start on this view. There you go. All right. The next view that we have is the right side view. Notice the location here once again. So on this three-dimensional box, we have our top view, our front view, and our right side view. These stay in this orientation. So that's our right side view, that's our front side view, and then this is our top view. The right side view is in correlation, sharing the same depth as our top view and the same height as our front view. Notice I didn't add any dimensions here because they're already provided right here. And they're already provided right here. We also want to note that the top view shares the same width between the front view. So this will be our width right here. Right. So the reason we have this layout is because we can see the alignment between all our shared edges. So each view is lined up to show whoever's looking at it a full picture of what that object is. In some cases, we would need other views. And in that case, we go to the open box concept. So if I took a cardboard box and I opened it up, I would have my top view, my front view, my right side view, my left side view, my bottom, and my back. So we will always use, or engineers, architects, people will always use the most common views, which are our top, our front, and our right. If we need to give more details or more explanations, that's when we start using the other views that are needed, and we will line them up exactly in this formation to help the viewer see and manipulate in their mind's eye how that object or product is made or looks. Okay, so we saw what the different views are. Let's try it out. The first thing we have to note is that I put in the top right corner
our isometric view, which is also our 3D view. It's isometric because it starts on an edge and comes out on two angles from the plane. Now, a plane is just, this was flat, and then you see that edge, that flat space is our plane. So back here, at the end of the box, you can say there's another plane. And I know that some people have made some boxes this way, or cubes, by just connecting these pieces. Now, once again, this is also a separate plane. So once again, I did the glass box without knowing, but I'm showing you the different planes that are existing. All right, so now we're going to begin making an orthographic projection of our life cereal box. So I am going to start with the front view, because that to me is the easiest. So the front view is just going to be a square. And on the square, I can even add some details, life. The right side view would be next, and I want to project it or align it so that they share the same height. And I know that the sizing is slightly different. It's not as wide as that front view, but it's the same height. And now I'm going to go to my top view. My top view shares the same width as my front view, but also the same depth as my right side view. So I know that that size is going to be about the same. I also know from looking back that there is an extra edge in there because there's two parts, and I want to draw that other line. Notice how dark these lines are. These are called our object lines. So as we continue going through orthographic projections and technical drawings, we're realizing that each line has a meaning. And these lines that have meanings are also known as the alphabet lines, because they have their own language. So an object line is something that's thick and dark. Notice I have these dashed lines. So if I was to draw this with a regular piece of paper, I'd have a very thin line coming through to help me identify my alignment. That thin line is known as a construction line. A construction line. So a construction line is a very thin line. And it's a thin line because it's supposed to be a guide. In the end, for all these construction lines, if I was using paper, I would go very lightly. And then once I'm done and I don't need them anymore, I would erase them. See if I can erase all of these so that they would all just disappear. And then, because I was using them as guides, I would know that my views would be aligned, meaning all those edges would line up, but it wouldn't disrupt or take away from my view. So a construction line, once again, is a very thin line used as a guide to help you draw. So in this case, it was to help align our views. Okay, so let's take what we just reviewed. I have a picture of a book, a great one called Beautiful Oops. It's in its isometric form. What I want you to do now is draw me the top front and right side view. Keep in mind, I'm looking for alignment. You are using the proper view orientation, and I can't wait to see what